Hello and welcome. In previous videos, we looked at graphing a piecewise function given its equation, or writing the equation of a piecewise function given its graph. In this video, we will write the equation of a piecewise function to model real-world phenomena. So for example, many southwestern states have a limited water supply, and some state governments try to control consumption by manipulating the cost of water usage. Suppose for the first 5,000 gallons a household uses per month, the charge is 5 cents per gallon. So we have a constant rate of change, 5 cents per gallon. And after 5,000 gallons is used, the charge doubles to 10 cents per gallon. And that's also a constant rate of change. So we do know that we're going to have some type of linear functions modeling these situations. Determine a piecewise function C of W that models the monthly cost of water as a function of the number of gallons of water used in a month. So as stated, we know that we're going to have a linear function, and for the first 5,000 gallons, we know that it's just 5 cents per gallon. So 5 cents per gallon W is true as long as the amount of water used is between 0 and 5,000 gallons. So that would be the first piece of our piecewise function. The second piece is a little more challenging. Let's actually make a table to see what's going to happen. So if after 5,000 gallons is used, the charge doubles. So we'll look at W, the amount of water used in gallons, and what the cost would be. So let's suppose a family used 6,000 gallons of water. What it is important to realize is that for the first 5,000 gallons, they're still charged 5 cents. So we might just want to make a note here that 5,000 times 5 cents per gallon is $250. So they're going to be charged $250 for the first 5,000 gallons. And then for the excess, so that extra 1,000 gallons they used, that's where they're going to be charged 10 cents. So as another example, let's say a family used 8,000 gallons of water. Again, for the first 5,000 gallons of water, they're only charged 5 cents per gallon. So for the first 5,000 gallons, they're charged $250. And then they're going to be charged 10 cents per gallon, but only for the excess gallons beyond 5,000. So 8,000 is 3,000 over that initial 5,000. So we could think of it like this. We took 10 cents per gallon and we multiplied that by 6,000 minus 5,000. Or when we had 8,000 gallons of water used, we took the 10 cents and we multiplied it by 8,000 minus 5,000. So in general, if a family uses W gallons of water, where W is greater than 5,000, we're taking the $250 for the first 5,000 gallons, and then we're adding the excess, so what was beyond 5,000, and we find that by W minus 5,000 times the 10 cents. And that actually simplifies to 10 cents times W minus 250. So I'll let you check that this actually reduces as I stated. But that is, again, that formula, that piece is true when they exceed 5,000 gallons. So this would be our piecewise function that models the cost, the monthly cost of water as a function of the number of gallons of water used in a month. So let's see how we would use this to calculate some different values. So we have our piecewise function, C of W. We know it models the monthly cost of water as a function of the number of gallons of water used in a month. So how much would it cost for a household that uses 9,500 gallons of water? So a couple things to think about here. This first piece corresponds to the 5 cents per gallon when they use between 0 and 5,000 gallons of water. And the second piece corresponds to when they use in excess of 5,000 gallons of water. So obviously 9,500 gallons of water is in excess of 5,000. If we were estimating, 9,500 might be about here. So we're going to try to find the output value when the input was 9,500. So we want to find C of 9,500. 9,500 is greater than 5,000. So we'll use the second piece, 10 cents times 9,500 minus 250. And we see that we get $700. Which looks about right based on the estimating in our graph. So in other words, it would cost $700 for a household that used 9,500 gallons of water. Let's look at one more example. We have our same piecewise function. So if between 0 and 5,000 gallons of water usage is represented by the first linear piece, and then beyond 5,000 gallons of water is the second piece of the function. And now we're asked to determine the amount of water used if a household's monthly cost of water was $150. So here we have to think about which piece of the function corresponds to a cost of $150. Well, remember that C of 5,000, so 5,000 gallons of water, corresponded to a monthly cost of $250. And we're interested in finding the amount of water used when the monthly cost was $150, which is less than $250. So what that tells us is that we can use the first piece to determine the amount of water usage that would result in a monthly cost of $150. The graph also satisfies this. So $150 is maybe about there. And so we see at $150, the cost is going to intersect the first piece of our piecewise function. All right, so if we solve for W, we find out that W would equal 3,000 gallons of water, and we can just check the first piece, 5 cents per gallon, is valid when the water usage is between 0 and 5,000 gallons. And the answer we came up with was 3,000 gallons, which is indeed between 0 and 5,000. So that confirms that we used the correct piece of this function to answer this question. In other words, it would cost $150 for a household who used 3,000 gallons of water in 1 month.